Look at the first question. Given n of xi is equal to 64 and a 29 and a union b complement 8 and a intersection b is equal to 12, find these things. So the first thing that we'll do is we'll draw a Venn diagram and we'll put the values there. Yeah. So this is the solution I've made. So this is my xi. So the number of elements in xi are 64. So this is a, this is b. Okay. Now I'll explain it. First I'll explain it here, then on the solution. So this is 64. Universal set has 64 elements. So A is 29. A is 29. So this total has 29. I have to find B, but there is some other information which is given to me. So n of A intersection B is 12. So what I understand is that this part, this intersection part would be 12. Now, we need to understand this well, that if this intersection part is 12 and whole of A is 29, then the part which is exclusively in A, which can also be written as A minus B. What I mean to say is that this part would be 29 minus 12. So 29 minus 12 would be 17. So this part would be, which is exclusively in A, which is not in B. So this part would be 17. Okay. So we have used this information, we have used this information, we have used this information. Now A union B complement is equal to A. So A union B. So this whole would be A union, this whole would be A union B. A union B complement is 8. So this part, which is neither in A or in B, this part, this whole of this part would be 8. Now, what we need to understand, I'll show you in this figure. So this part is 17. The exclusive A part, which is only in A, is 17. Let me rub this now. The intersection part is 12. The intersection part is 12. The part which is neither in A or in B is 8. And what I need to find is what I have been given is that xi is 64. What I need to find is what I need to find is n of b. So what I'll do is this exclusive b part. Exclusive b part implies that b minus a, the part which is exclusively in b, but no part is in a. So this b minus a, this orange is the b minus a part. This b minus a part I denoted by x. Now, if I have to form an equation, if I look at this carefully, then what I'll find is that 17, the part which is exclusively in A, it is not in B, 17 plus 12. 12 are the elements which are both in A and B, plus x, the part which is exclusively in B. Any part which is A has been subtracted, so this is B minus A part, plus the elements which are neither in A nor in B. If we add all of these together, what we will get is the universal set, 64. I hope this is clear. Basically, what I'm trying to tell you is that this part is A minus B. This part is A intersection B. This part is B minus A. And So what I'm trying to tell you is that if this part is A minus B, so this part is A minus B. This part is A intersection. This part is B minus A. And this part is something which is neither in A nor in B. And this is the universal, uh, the number of elements in the universal set. So let me denote this part as X. Let me denote this part as 8. Why 8? Because this 8. These 8 elements are neither in A nor in B, but they are in the universal set. So what I'm trying to tell you is that if I add all of these together, so number of elements in A minus B plus number of elements in A intersection B plus number of elements in B minus A plus 8, these would be all the number of elements in the universal set. So this step is basically this step. Now I hope this should be clear. So this is what I have written here. This is what I have written here, and therefore x is equal to 27. So the part of B which is exclusively in B, so this orange part, this x is equal to 27. This x is equal to 27. So the question which is being asked is n of B. So n of B would be equal to 27 plus 12. 27 plus 12. So this is what I have done here. So 27 plus 12 would be 39. So number of elements number of elements in B would be 39. The second part that they are asking is B minus A. So B minus A would be from whole of this B, subtract whatever part is A. So this part would be 27 exclusively. This is 27. Then they are asking me number of elements in B complement. So except B, anything which is there in the universal set. So whenever they are talking about the complement, they are talking about the universal set. So 64 minus 39. So take the universal set, subtract number of elements of B from it, and what you are left with is n of B complement. So this is a great question to understand the nitty-gritty, and in case of any doubt, please let me know. Please mention in the comment section. So let's go to the next question.